Look up at the night sky. Really look at it, not at a screen, not at a photo, at the real sky above you. It feels endless, quiet, dark, and that darkness feels natural. We grow up believing the night sky is dark because there are no lights there, because space is empty, because stars are far away. But this simple explanation hides a problem, a very deep problem. Because if the universe were infinite, filled with stars everywhere, and had existed forever, the night sky should not be dark at all. It should be completely bright. Every direction, every point, every moment. So why isn't it? This question has haunted astronomers for centuries. It is not a modern mystery. It is one of the oldest unsolved questions in cosmology, and it has a name, Olbers Paradox. At first glance it sounds simple, but its answer reshapes how we understand the universe itself. Let's begin slowly. Imagine an infinite universe. No edge, no center. Stars spread evenly in all directions. Now imagine looking at the sky. If you look in any direction, your line of sight should eventually hit a star. If not a nearby one, then a distant one. If not that, then another even farther away. In an infinite universe, every line of sight ends on a star, which means every patch of sky should glow like the surface of a star. The night sky should be as bright as the sun. But it isn't. It's dark. This is not a trick. This is not philosophical. This is a mathematical contradiction. For a long time, scientists tried to avoid the problem. They said stars might absorb light. But stars absorb and emit equally. They cannot hide infinite brightness. Others said dust blocks the light. But dust heats up and glows. It also cannot hide infinite light. The darkness remained. This meant one thing. Our assumptions about the universe were wrong. Something fundamental about space, time, or stars had to change. The first clue is distance. Stars are far away, extremely far. Light takes time to travel. So maybe the universe is not old enough for all light to reach us. This idea is important because the universe has a beginning. It is about 13.8 billion years old. Light cannot arrive from beyond that limit. This means we can only see a finite portion of the universe. That alone already reduces brightness. But it does not fully solve the problem. Even within that visible region, there are still billions of galaxies, each with billions of stars. That should still be bright. But it's not. So there must be more. The second clue is expansion. The universe is not static. It is expanding. Every galaxy is moving away from every other galaxy, not through space, but with space. As space expands, light traveling through it stretches. This stretching shifts light toward longer wavelengths. Visible light becomes infrared. Infrared becomes microwave. Eventually, light becomes so stretched that it is no longer visible. It fades into darkness. This means distant starlight loses energy as it travels. Not because it is absorbed, but because space itself changes. The universe actively dims its own light. This is a crucial idea. The darkness of the night sky is not passive. It is dynamic. But even expansion alone is not the full story. There is a third factor. Stars are not eternal. They are born, they shine, they die. The universe has not always had stars. There was a time before the first star ignited. For hundreds of millions of years after the universe began, there was complete darkness. No stars, no galaxies, no visible light. This period is known as the cosmic dark ages. The night sky is dark because light had to be created first. Stars did not exist forever. They appeared gradually. Even today, stars are not evenly distributed. They cluster into galaxies. Galaxies cluster into groups. Between them are vast regions with almost nothing. This uneven structure creates darkness. So the night sky is dark because the universe has a finite age. Light takes time to travel. Space is expanding. Light loses energy. Stars are not eternal. Matter is unevenly distributed. All of these factors work together. Darkness is not emptiness. It is information. It tells us the universe is evolving. Now consider something unsettling. Every star you see at night is already old. Some are already dead. Their light is a message from the past. When you look at the sky, you are not seeing the universe as it is. You are seeing it as it was. The darkness between stars is just as meaningful as the stars themselves. That darkness contains the earliest light ever released. Not from stars, but from the universe itself. About 380,000 years after the beginning, the universe cooled enough for light to travel freely. That light still exists, but it has been stretched so much by expansion that it is now microwave radiation. It fills the entire universe. This faint glow is called the cosmic microwave background. It is everywhere, even in the darkness. The night sky is not truly dark. It is quietly glowing in wavelengths we cannot see. Our eyes are blind to most of reality. The darkness is not absence. It is limitation. This realization changes perspective. The night sky is not empty space. It is layered with time. Every dark region marks a boundary, a limit, a transition between eras. The farther you look, the earlier you see. Eventually, you reach a time before stars existed, before galaxies, before structure. Beyond that, there is nothing to see. Not because nothing exists, but because light had not yet been created. The darkness marks the edge of vision, not the edge of reality. This is why the night sky is one of the strongest pieces of evidence that the universe had a beginning. If the universe were eternal, the sky would blaze. It does not. Darkness is proof. It proves the universe is young, dynamic, and evolving. The next time you look up at night, remember this. You are not looking into emptiness. You are looking into history, into limits imposed by time, into light stretched thin, into stars that have not yet existed. The night sky is dark because the universe is telling you its story, quietly, and we are only just learning how to read it. But there is one more layer to this darkness that makes it even more profound. The night sky is not only dark because of what exists, it is dark because of what cannot exist anymore. Stars burn fuel. They convert matter into light, and fuel is not infinite. Every star that shines is slowly moving toward an end. Some end quietly. Others end violently. But all of them end. This means the universe is not only expanding, it is aging. The darkness of the night sky is also a glimpse of the future. Over immense timescales, stars will become rarer. Galaxies will fade. The sky will grow darker still, not suddenly, but gradually. The universe is moving from a bright beginning toward a darker state. This does not mean nothing will remain, but it does mean light will become harder to find. In the far future, distant galaxies will move beyond visibility. Not because they disappear, but because their light can no longer reach us. The night sky will shrink. What we see today is already limited. Every generation of observers sees less than the one before. This gives the present moment a strange importance. We exist at a time when the universe is still visible, when stars still burn, when galaxies can still be seen. The darkness reminds us that this window is temporary. And yet, even as the universe dims, it continues to leave traces. Light echoes, radiation backgrounds, faint signals from ancient events. Even when stars are gone, the universe will still remember that they once existed. The darkness will not erase history. It will preserve it quietly. In this way, darkness is not the end of information. It is the storage of it. Every dark region of the sky is filled with signals beyond human senses: radio waves, microwaves, gravitational ripples. The universe is never silent, only quiet. The night sky teaches us humility. It shows us that reality is far larger than what we can perceive. Our eyes evolved for survival on a small planet, not for reading the universe. The darkness is not a failure of nature. It is a reminder of our limits. And yet, despite those limits, we have learned to listen. We build instruments. We extend our senses. We detect what eyes cannot see. From this darkness, we have extracted the age of the universe, its composition, its history. The night sky looks empty, but it is full of answers. It asks nothing of us except patience. The more quietly we observe, the more it reveals. Darkness is not ignorance. It is an invitation to look deeper, to wait longer, to think slower. The universe does not rush, and neither should we. Because the night sky is dark, not because there is nothing there, but because there is too much for our senses to see. And that is what makes it beautiful.